All right. So we're going to get on our last official section of this walkthrough. So we're going to go with it's going to be basically the other services. Right? This is going to be an etc. errata or additional services that would be in the security specialty exam, but they aren't necessarily the ones that would be classified under one major domain or not. So let's start with direct connect. So what is direct connect? This is a dedicated private network connection between your on-prem data center or your co-location facility and AWS. Unlike VPNs, Direct Connect does not use the public internet, and it results in consistent latency, higher throughput, and greater reliability. So why would you use this? You have a private network path. This bypasses the internet to access the AWS resources. You have high throughput, which is ideal for moving large data sets like analytics workloads. You have stable latency. This will ensure consistent performance, especially for real-time applications. It's hybrid cloud ready, which means it supports seamless extension of on-prem infrastructure into AWS. There's lower data transfer costs. This is typically cheaper than transferring any information via internet gateway. And it supports IPv4 and 6, with both protocols being compatible. So how does it work? Here's some core components of it. So Direct Connect has a location. So the physical facility is where AWS connects to your network via cross connect. Then there's customer or partner routers, right? These are required in a co-location facility. There's also a virtual private gateway, which is attached to your VPC to enable private routing. There's virtual interfaces, VIFs. These are logical connections used to route traffic. Within this, there is a private VIF, which is for accessing private AWS resources in your VPC, like a EC2. And then there's a public VIF, which is for accessing public AWS services, like your database or your storage buckets over Direct Connect. And then there's Direct Connect Gateway, which is there to aggregate access to multiple VPCs in multiple regions. Okay, so let's see. I'm trying to think where. So a couple of interesting ports about it. Okay, there's different types of connection types. There's a dedicated connection. This is through a physical port owned by you, and the speed for this can be 1, 10, or 100 gigabits per second. Then there's a hosted connection, which is provisioned by an AWS partner, and that can be between 50 megabits per second and 10 gigabits per second. And there's a hosted VIF, which is a virtual interface on a partner's direct connect connection. And this has a flexible speed, so this can be a little variable. But what's the setup time? This typically takes about 1 month. And for fast data transfer needs, this is not suitable. You should definitely choose S3 transfer acceleration, Snowball, or a VPN. So this is something that you need for more long-term planning and suitability. So here's some security considerations. There's no encryption by default. Direct Connect is private, but not encrypted. With concerning IPsec VPNs over Direct Connect, you need to combine Direct Connect with a VPN for end-to-end encryption. And then for private subnet access, you need to access EC2s and other VPC resources without the internet. Okay. One of the better parts about it is that it can be very resilient. So you can have two Direct Connect locations, each with one Direct Connect connection. And the benefit of this is that it protects against one location's failing. So a couple of tips for the exam, right? If you need to transfer 20 terabytes within 30 days, Direct Connect is not ideal, right? Think of something like Snowball or S3 acceleration, which is for more quicker setup and transfer. If you need secure real-time feed with a private channel, Direct Connect is your option. And you can add a VPN for encryption. If you need multiple VPCs across regions, Direct Connect Gateway, like we mentioned earlier, would be an option. If you need maximum resiliency for mission critical applications, two direct connect locations with two connections each would be a great setup for this. And if you want encrypted traffic over private channels, then direct connect paired with a VPN would be an ideal setup. So let's go and see what this looks like in the console. Okay, so you can see this here. All right, and how would you find this? In the GUI. All right, let's see here. Probably migration and transfer. No, I would have thought that. There it is. Okay, so it's under networking and content delivery and then direct connect. All right, so what you're gonna do, go here, click create connection. Then you have the wizard, or you can do one at a time connection for the classic version. All right, so let's go with the wizard. Okay, what's the resiliency level? Right, so you want maximum resiliency with, let's see, one region, and then two connections at each direct connection. You can have high resiliency with his two direct connects with one connection, or you have a dev test where you have two connections at one direct connect. All right, so maximum would be this. Let's go for that. Select next. Bandwidth. I mean, this is going to cost, depending on how much egress you have more than anything. Let's just set it at 10 gigabits. You set the first location provider, AT&T. Second location, let's say Reston. Next rotation, let's be consistent across this. Look at the additional settings. All right, so you're talking about a lot of stuff that goes into configuration. Okay. Oh, Mac support. Sorry. So this is for compatible routers for the end of your dedicated connection, and tags, which would be good for your cost association and your security considerations. Click next, and so you see this is the connection summary. You would hit create. All right, but we're not going to do that. So let's go to virtual interfaces, right? So within here, you go to virtual interface. You start to select your type. It's usually private, public, and transit. Okay, so within this, let's say private. From here, you can select your virtual interface name, my practice, VIF, connection type. Okay, physical connection on the new interface. So this would be connecting with your direct connect, then your account or another account, direct connect gateway. There you go. So this should have been the direct connect. And then here's the direct connect gateway that you would add. Then your VLAN. So this would be the number for the new interface range. And then your BGP for dynamic routing, right? And then you click to create the virtual interface, right? So this would revolve around a lot of your network segmentation and isolation, your number, your BGP um, autonomous number for routing, and then the BGP, what do you call it? Authentication and customer gateway, right? So this would set this up and able to have either a private, public, or transit, right? For the public, it's a little bit different. Let's go here. All right, so with public, you could select, let's see, same name, your connection. You could set this to an S3. So you could have this for your connection there. And then, or you could do CloudFront, Route 53, or another API endpoint. Okay. And you would have similar connections for your VLAN, your BGP, and then how do you set your addresses for your interface for the IPv4 or 6, your peer router for BGP, and then your Amazon peer IP, right? So this would show the list of IPs that you want to advertise for the interface. And then within this, you'd have to determine the route filtering. So which public AWS services would be accessible to say like an S3, how the on-prem configuration for public prefixes will work. And then you need to go back and consider any IAM policies for the public services and whether they should work with this. And then you need to work with your security to understand that CloudTrail should be logging all public service usage. All right. And now I have not used transit, but this would seem to show that for transit gateway, this would be something along cross account for cross regional access for the information, and would be very similar to how you would consider the private, but you want to have this shared across multiple accounts. So this would operate similarly to the organization unit construct. All right. So let's cancel this. Let's see. Let's see. So you could do this virtual interface. Um, there's the transit gateways. Why is that there? Uh, that shouldn't be here. Let's see if I can delete this. Oh boy. All right, so I deleted that transit gateway. I don't know how that got there. All right, so there's also a way that you can create the VPN tunnel. So we go to VPN. Let me see. Yeah. All right, so you create a VPN tunnel. Um, so within this, you'd have to configure your customer gateway to connect with this for your on-premises VPN endpoint. You go to your virtual private gateway to create the virtual private gateway for the AWS VPN endpoint. And then you create the site-to-site connection come on. All right, for the VPNs to work with encrypted tunnels over direct connect. All right, so within this, you'd have your IP addresses, your ASN for your autonomous number for BGP, and then you'd make sure to tag it correctly for your customer gateway, for your VPN connection, and then set whether or not you want it static, which it should not be set as static, which is why you would have BGP. And then after that, you would need to do direct connect gateways. Let's see what you would set up over here. So you click create, name it, my practice DC gateway, set the ASN for it, and then you click create. At this point, then you could attach this, connect multiple VPCs across different regions, and then you can route this to work correctly. So what that would mean would be setting correct tags to how you have it configured with your association with your VPC, and then the correct IDs and CIDRs and the allowed prefixes. All right, and then with Transit Gateway, which we go back over here, your Transit Gateway. Your Transit Gateway, you have to set this up. This would be done basically to segment the networks, right? So you have different routing for different domains for different environments. If you want to have, something dev, prod, test, whatever, or if you had this for different accounts by, business units, finance, HR, etc. Right? And then within this, you'd have your firewall configured. So let's say security. You can go into Security Hub and then configure that to have firewall inspection points along the way. All right. Which I don't have Security Hub configured, so you have to be a little patient to visualize this yourself. Okay, so you'd add a widget to make sure that you could be able to monitor this. No? Is it not there? Oh, no. Or did I not have this turned on? No, that's not it. Fire. So you probably check this by firewalls, or you can go over here into the VPC section. Yeah, here you go. And check for firewalls here. And then start creating firewalls to monitor this as well. And then for anything around resilience, you'd want to know where your multiple locations were when we talked about that when creating it, what the connections are for direct connect. So you'd have separate connections per location. And if you had different providers, AT&T, Verizon, or whatever provider. And then if you needed to have this rollover, you'd need a load balancer, which we would find. Load balancer under the EC2, which you could configure to have additional cross-connection balancing for the routing. All right, so there's a lot that goes over into this. I'm trying to think what else you would need. Well, obviously for monitoring and logging, you want to make sure CloudTrail is activated. So once you get that all set up, you go to CloudTrail. And then from here, you could try the Direct Connect API logging, create a trail, set the name, let's say Direct Connect logging, right? Set the bucket for where the log should go. the encryption for the KMS, go forward, DCL. Yeah, let's do just that. And you choose your types from your data types, what you want to get here, read, write, and then expand this. And then you'd be able to go forward. Okay. From there, you'd be able to add anything else you need for this. One thing that you could do for optimization would be able to go and add CloudWatch metrics. So with CloudWatch metrics, you could add enough to monitor the network activity, right? So that would mean, what's your connection state? Like, is everything connected? How is your BGP working? So you can see the session status. If there's any packet loss along with your network connectivity and your bandwidth utilization. So you think about what the capacity is and then how you plan for everything on your intranet and VPC interconnected network. And outside of that, once your CloudTrail is activated and your logging and monitoring for your resource allocation is activated, you should be good to go. From there, you could consider doing AWS backup to back up your primary direct to connect configurations, and then any material that you transferred over. So within this, you want to make sure for the exam that you're aware of the architecture of how this is connected, which is basically going through everything in direct connect. How would you actually configure this? In what order, which you just went over? What does the hybrid architecture mean between on-prem versus in the cloud? So that public, private, transit gateway, transit virtual interfaces, the multi-region connectivity, so that those two connections through two direct connects, and then, well, that would be more resiliency. But basically, how would you route that within your cloud system via transit gateways or with the direct connect gateways? And then where would it integrate? So would that be with VPCs, with transit gateway, or any other service connectivity? And then you'd want to make sure that for your compliance, you have CloudTrail set up with audit logging and monitoring for this within a secured S3 bucket. But outside of that, I think that covers Direct Connect pretty well. Let's go to the next one, ECR, Elastic Container Registry. Okay, so this is for your Docker. All right, so what is ECR? One, let's find this here. This would likely be in containers. Containers, Elastic Container Registry. So what is this? This is a managed Docker container image registry. So it lets you store, manage, and deploy container images securely on AWS. So it's like a private version of Docker Hub. You can make some public, but typically you want to make your images and containers private. So this is natively integrated with AWS and works with storage services like ECS, EKS, and code build, right? So within this, you have a lot of features like IAM-based access control, which means to access ECR, this would be secured by IAM policies. So any EC2 or ECS, the container service, would have to have an IAM role granting ECR permission, right? So this would be how you download the container for your layer. Within this, you have tagging and versioning. So the ECR would support image tags and immutable versioning for release tracking. So you could have v1-1.2.1, .2.3.4, and would not be able to overwrite. So you'd have good logging and tracking. Vulnerability scanning. So you can automatically scan images for known common vulnerabilities using Inspector or the built-in scanner. Then you have lifecycle policies where you can delete older or unused images to save on storage. And then within this, you also have image pooling. So you could use this with ECS, EC2s, or EKS. So your nodes would pull images from ECR when launching containers. But here's a little tip. A lot of people won't use this when it comes to their cloud environment. They might build images in the cloud, but they'll typically use a personal or third party for actually managing their containers. All right. But this is good to know because some places might want to be fully AWS. And if they are, then you know where to go. Okay, but remember two things. When you have it set up for private, that's the default, and it's only accessible by authorized IAM users or accounts. If you have it for public, then this publishes images to ECR's public gallery for global access. All right, so what do we want to talk about? So for the exam, you should know that if you want to store Docker images privately on AWS, this is what you would use. For secure access to Docker images for ECS, you can use this with the correct IAM role. That would be ECR colon, and then with a star or with a specific permission, right? You can scan Docker images for vulnerabilities, post push, which enables the image scanning, right? If you need to host open source images on AWS, you can use this in a public repo. If you need to clean up unused images, you can use lifecycle policies to do that. And you can also, if ECR permissions are denied, you can go through the IAM policies and RBAC, the resource-based access. Well, it's another RBAC, and handle it there. But here's the private and the public and all the settings for this. So let's go see how you set this up. So we go here. Let's see, create the private repo. And let's say container, practice. So remember, these containers are region specific. We've done this before. So you want to make the tags mutable or immutable. That's up to you. We'll set this for immutable. How about that? We'll have this encryption set here. Scans, we'll set that here. Now we're not going to have any scans, but we're just going through this. So then you want to make sure that immutability is there for tag or for tagging and for production, right? So if it's going there for production, then it should be set to immutable. So if you have a production load, it won't revert back to an older version, all right? Then you go to your repo. Let's see. We don't have any images here. Well, let's see the permissions. All right, so you can configure permissions on this. These would be JSON-based access, right? So let's edit the policy, and I'll show you one that would show you what this would look for, okay? So this policy would allow push-pull on the account number and the role, right? That would allow this. You need to create those roles if they don't already exist and assign the correct permissions to those roles. And what are the actions permitted, right? Batch check layer, get download URL, batch get image, get authorization token, and then you would go forward, right? So you could put the image, upload the layer part. I mean, this is pretty comprehensive, okay? And then from there, you could configure image scanning, all right? So, images. All right, so here is where you would do this. And this button would be the scan. How do I show? How can I highlight that? There you go. This last button that's blue, highlighted. All right, so when you have this configured, you can automatically scan new images, and the basic scan will look for standard vulnerabilities from the database. But there's an advanced scan where Amazon Inspector will do the scan with it's integrated and on, right? Remember, that does have a cost. And then you can have continuous monitoring for ongoing vulnerability detection. All right. So after that, with the scan results, you can, if they were here, you'd click on the details tab, and then you would look for vulnerability count. So that would be how many criticals, highs, or mediums, or lows, and for the severity, and then any of the vulnerability details. So what the exposure information is, what are suggested remediations, or why it's vulnerable. Then you could look for the package information, like affected packages or versioning, and this could be anything as far as allows. It could be for anything, right? It could be for having too much non-root user access, not having group users. There's a long list that you go for. And then you go for the lifecycle policy, right? So if you go here, this is where you can set lifecycles to revert, keep, delete, remove. So basically you can set this up to keep only signed production images, right? And you could have this keep the latest 2, 3, 4, 5, right? And you can set it for an expiration date. And then you can set this to delete development images after X amount of days, right? It can be 5 days, 15 days, 30 days, whatever you need. Then you can have a rule to, let's say, remove untagged images, right? And you can set this to look at this over the next 5, 10, 15 days, however you need to iterate that. All right, and then let's see. You also want to make sure that your images have signing and verification. I'm trying to think, where would that be done? Um, so your Docker content will have trust integration. And so with that, you'll have a notary server that'll have digital signing verification, a signing key for PKI-based authentication, and you'll have trust policies where the signer validations will be checked to see if they're met. And then you can do that within code build to make sure everything runs smoothly. And then once you have that image set, then you could integrate this in your CI/CD um, pipeline, right? And so with this, you'd follow standard best practices. That could be everything from least privileges for your IAM roles, secrets management for any credentials that would be in your registry for anything along your pipeline, or you could have it for, let's say, separate build environments for different levels of security. So dev could be more open, um, RC could be more restrictive, and production could be even more restrictive. And you have audit logging set up, right, so that your pipeline activity is tracked. Okay, so there's a lot of that can go on. And then what you could do for this as well would be able to create a VPC endpoint. So, okay, there we go. So within the endpoint, right, you go over here. And so you do this, basically, you choose the target VPC, you create information to connect. Let's see, you create a security group for this, you set the ports and protocols for this, and then you get this set up for what do you call it? An encrypted transfer for the container instances, and then you could point this at the security groups, and then the container registry for private access, and from there, you would understand the benefits of the VPC endpoint, right? So this would allow private network traffic. So ECR does not have to access the internet gateway, and then the traffic would stay within the AWS network. And then you could reduce NAT gateway data transfer costs, so that egress charge. And then you'd make sure that with this, the private network requirement would be met. So there's a lot of benefits once you start configuring this correctly. And then after you have this set up so that it can run, then you make sure that CloudTrail was integrated over, let's see, CloudTrail, right? And so within this, you can set up so that you have the repository, let's see, with the trail. Ooh, what is that? Oh, bucket does exist. Hmm. Yeah, let's delete that. Yeah, that's interesting. Yeah, so you delete that. I deleted that. So with this, you'd be able to create, delete, or modify any trails. And then within this, you would have the logging set up so that you could monitor the creation, deletion, or modification of trails. I'm sorry, of images or containers. You could monitor the image pushes, pulls, or deletions. You could see the policy changes for the repos and registries within. You could see the access patterns for the users and services, right? And then you could also set up CloudWatch within this. And then you could monitor how much is there for the repo, like how much storage is getting utilized. You could see the pull or push counts to see the usage patterns. You could look at scan results here for vulnerability trends, and then you could see any API errors, right? So access or authentication issues, right? And then I think you could do, if you did cross account access, which that would be useful if you had your environment set up, dev in one account, prod in another account. You could use this. You could use cross account and able to have all of your containers in a secured separate account and then pull them cross account through something like RAM, and then use this to deploy your information. And you would limit yourself from having service impersonation, right? So you could have this set up so that your IAM roles would have conditions to restrict access to specific resources, like just the ECR. So you won't have external or extraneous resources being created. You could limit access to the specific accounts, like just dev or just prod. So then if you wanted to have a bunch of different test environments, or if you have business units, then they wouldn't have access, right? Just the test units. And then you could set up principal validation, right? So you could verify service accounts and service requests on this, all right? Okay. A couple things to remember for the exam, okay? Think about the container registry security. A couple things that you should always note. The private repo is best. It's obviously more secure than a public repo. How does IAM integrate with this? So what are you using for your control over registry operations and use? What does your image scanning look like? What CVEs, the common vulnerabilities, are going to be detected, and how is that going to be assessed? And then what encryption are you going to have within this to make sure that only what's able to access is able to access it, right? Um, let's see. Let's go over to ECS. Okay, so where is this? Oops, no, let's go back here. Let's click on this. Okay, so ECS, containers. Okay, so ECS, more specifically, okay, so ECS security. All right, so let's think about this. So ECS has a security feature um, that works with and supports the secure injections of secrets and configuration values into containers at runtime. And this works with Secrets Manager, which we'll see. Secrets Manager and Parameter Store. Okay, Parameter Store. All right, so this allows sensitive information, right? Secrets Manager allows stuff like API keys, database passwords, or tokens. Parameter Store adds stuff like your VPC configuration, so like your network protocols, your IP address ranges, your CIDR blocks, and it does this without hard coding this into the container image or any tasks. So here's a couple things to remember along the lines here. So what is Secrets Manager? This manages those secrets, your credentials, supports automatic rotation. Your parameter store stores configurations like your VPC, CIDRs, your EC2, IDs or ARNs, and your API keys, right? The ECS task is this references sequence by ARN, the resource number, or name for environment variable injection. And then you have to worry about the IAM roles where the ECS task can execute the role, right? And then that must have explicit permission to access the secrets. And then you need to also make sure that you have encryption enabled through KMS so that if you're using AWS KMS, ECS will also need decrypt permission. The benefits of this would be no hard-coded secrets, fine-grained control, automatic rotation, and consistent across services. Okay. So let's see, what else would we want to cover? Um, let's go over to EKS. Okay, so EKS. All right, we'll click over here. Containers, EKS. So what is EKS? This is AWS's fully managed Kubernetes control plane service. So it simplifies the deploying, operating, and scaling containerized applications using Kubernetes, right? So EKS is owned by AWS, and it's an abstract way to control your Kubernetes operations. It lets you focus on your application workloads. The nodes would be the EC2 instances or Fargate managed compute to run your application pods. And then the pods would be the smallest deployable units in Kubernetes. So they would encapsulate one or more containers, which we just talked about. So what can be logged in EKS? And this is probably going to come up, maybe not on this particular exam, but the EKS dashboard, you should be aware of that. But it's coming along, right? So what you're going to log within this would be your pods, right? So this will be anything generated by running your application containers. This will be useful for application level debugging. Your nodes, which will be the infrastructural level logs from underlying EC2. So you could look at this with kubelet, systemd, or anything else along those lines. And then you have your control plane. This is the AWS managed infrastructure, and it'll include system events like API access, scheduling, and cluster activity. And then you'll have a default time to live for Kubernetes for about 60 minutes, and these events will be ephemeral and not persistent by default. But this will retain your logs for at least 60 minutes. And if you want to keep them longer, you have to export them to CloudWatch. So remember that AWS will provide the ability to log and monitor this for CloudWatch. And it'll log stuff like your API, your audit trail, some authenticator logs, some Kubernetes controller managers, Kubernetes schedulers. But to enable it, you have to go into the console or CloudWatch or even CloudFormation and then enable it from the start and create this for CloudWatch log group. Okay, so best practice for EKS would be make sure that you forward your logs to CloudWatch. Make sure you restrict your CloudWatch access with the IAM roles, and then use selective control when you're logging, right? And then once you have this integrated with this, you'll be able to see the log visualization and any events going through, either on AWS or third-party tools like Datadog, Prometheus. Yeah, so you should be good with that. All right, so we're going to go over Lambda security. All right, so Lambda, we'll just click on this button because I have this pinned here. But I think Lambda would be, this will be workloads, but what type of workloads? Will it be compute? Yeah, it'll be under compute. Okay, so this is event driven. Okay, so Lambda lets you run code without provisioning or managing servers like EC2s, right? So while it's serverless, it still requires security design. So when you're accessing other AWS services, working inside a VPC or managing sensitive data, you still have to be aware of this. So within this, you should always be aware that Lambda will require an execution role, and that'll determine what AWS services it can interact with, right? So you can have like, let's see. Okay, so here's a role example. How about this role example? This is a basic role that type that you could have, right? Basic execution role. So you could do something like upload log, CloudWatch logs. You could do something like connect to VPCs, read from a database. There's just a bunch of different things you could have this. So within this, Lambda would use its execution role to read event data from different sources. It could be from Kinesis, it could be from S3s, it could be from DynamoDB, from SQS, right? And you could have resource-based policies within this, right? So you can allow services like S3, SNS, or EventBridge, invoke your Lambda, and use resource policies, which would be similar to a bucket policy or SNS topic, and then be able to activate, right? So event-driven architecture. So one thing would be like you have an IAM identity policy, right? That IAM user call Lambda, that Lambda would trigger an event. You could have a resource policy, like S3 gets something gets dropped in an S3 bucket. The S3 bucket would trigger a Lambda from the event, right? So if you want to allow like an S3 to invoke Lambda when an object is uploaded, you could attach the resource-based policy to the Lambda function. And then within this, you could go to CloudWatch and enable and make sure that the Lambda execution role was set up there, and then also had permissions on it, right? To be able to create the log group, create the log stream, put log events, describe the log stream, all right? A couple of things. But by default, Lambda runs outside your VPC. In an AWS managed VPC, it can access the public internet and AWS services like DynamoDB or S3, but it cannot access private resources in your VPC like RDS or Elasticache. To access the VPC resources, you have to configure VPC networking for your Lambda. So that means you have to assign a VPC ID, select subnets, usually a private one, and then attach security groups. And then AWS will create ENIs or elastic network interfaces in your subnets to allow Lambda to connect to the VPC. All right. So I'm trying to think a couple of things you can remember. Yeah. Yeah, so a couple of best practices would be mindful of the IAM roles. How do you assign them for least privilege? Be aware of the logs so that you can grant the necessary CloudWatch permissions. Make sure you attach a VPC. Make sure you are aware of the resources that are being accessed by the Lambda. Make sure that you understand the ENI management when it's engaged with the VPC. and then understand the internet access, public internet access when it comes to NAT for any internet-bound lambdas. All right. For trusted deployments. All right, the AWS Signer is a fully managed code signing service that ensures the trust, integrity, and authenticity of your code before it's deployed. It uses digital signatures to verify that code has not been altered and originates from a trusted source. Okay. Let's see here. All right. So here's some core concepts to remember, right? So you get a code signing certificate, right? This is a cryptographic key pair used to sign code, and it's managed through AWS Certificate Manager. You also get a signing profile. All right. So this signing profile is a reusable configuration that defines how to sign your code, like with a signature algorithm or a certificate. And you have a digital signature. So this would be a cryptographic mechanism to ensure that the signed code is unmodified and trustworthy. And you get code verification so that at runtime, usually by a Lambda, the platform will verify the digital signature. And if verification fails, the code is not executed. Right. So this AWS Lambda and Signer integration is great. One, it's supported for zip-based Lambda functions only, so not container images. Two, you must sign your deployment package before uploading to Lambda. And three, enforces that only code signed by a trusted profile is executed. So the benefit of this is that it prevents the risk of running tampered, malicious, or unauthorized code. Okay, so this also works with something like Internet of Things devices, so that you have firmware installed on certain devices that has not been tampered with. All right, but then there's also the ability to revoke trust in signed code if you detect a compromise or want to block an old deployment. So you have the options with a command to revoke signature or revoke the signing profile, right? But remember, once revoked, the signatures are permanently invalidated. So the Lambda will fail signature checks and prevent execution. All right. So to remember this for the exam, the use case for this is to ensure integrity and authenticity of code. The Lambda scope is only for zip-based functions, not container images. The Internet of Things is supported with firmware signing to make sure that nothing has been maliciously applied or manipulated. And then when revoked, that doing this, it revokes individual signatures, not the entire profile, but it can revoke the profile as well. So you have to understand the difference between those two things. And then there's integration with the certificate manager, which manages the signing certificates. Okay, next we have AWS Verified Access. Let's see if I can find this. Verified Access. So this is a VPC feature. All right. So Verified Access is a zero trust network access, right? ZTNA. So this is a service that enables secure, fine-grained access to internal corporate applications, and it does not require traditional VPN. So this ensures that only authenticated and authorized users and devices can access your private applications over the internet. And this uses real-time identity and device validation. All right. So here's some core principles. So the zero trust model means that no user or device by default can access this. Each access request is validated based on identity, device posture, and policy. There's no VPN required, so employees can securely access internal applications over the public internet. And there's no per request verification. So authentication and authorization is evaluated continuously, not just at login. So how does it work, right? So you have an internal application that'll be hosted behind like a load balancer and a private subnet. It could also be tied to an elastic network interface. And you have a verified access point within, created here, right? And this acts as a gatekeeper between users and your internal applications. And within this, you'd have identity providers that would basically work with IAM Identity Center or like a third-party IDP like Okta or Auth0. And then you make sure your policies are configured to validate who is accessing it, what device they're using, and which app they're trying to access. So this would be like centralized policy management to ensure consistent enforcement. And then within this, once validated, the traffic will be routed to the load balancer or ENIs if it's in a public private subnet. And then you'd have something like WAF, the web application firewall, to protect the applications from web attacks like SQL injections or cross-site scripting, right? And then after that, you'd be able to have access logs sent to CloudWatch, and then from there, obviously to S3 or data firehose if you needed something more real time. And there's also third-party logging tools that you could be done too. So remember for this for the exam, it's zero trust. So understand the model. You verify the user and device on every request. There's no VPN. So it replaces the traditional VPN for secure internal access. IDP has options. This could be IAM Identity Center or any OIDC compatible ID protocol system, right? And it works with load balancers, elastic network interfaces, web application firewall, and logging services. And then the logs that are generated will go to CloudWatch Logs, S3, or Kinesis Firehose. And for policies, the policies will enforce who can access what and when based on identity and device status. All right, so what is AWS Glue? All right, so Glue is a fully managed ETL, right? That's extract, transform, load. So this is a service that's used to prepare and transform data for analytics. So it automates a lot of heavy lifting involved in data preparation and supports serverless execution. So where's some core capabilities? So you have ETL jobs, right? So this can extract from sources like S3, relational databases, and it can transform, so it can like filter or enrich and load this into targets like Redshift, right? It's serverless. There's no infrastructure management needed. So Glue handles resources and resource provisioning. Okay, there's a catalog. So there's a central metadata repository to store table definitions, schemas, and job metadata. And there's data crawlers that automatically scan data stores like S3, RDS, or DynamoDB, and it infers a schema. You might have to tinker with it, but it does a pretty good job. And then there's a data format version so that it can convert something like a CSV to Parquet for efficient queries within like Athena or Redshift. And then you can have a job automation where it'll trigger ETL jobs with an event bridge. So a Lambda when a new file hits S3 bucket, right? And within that, then you'll have Glue job bookmarks. So these will track job state to avoid reprocessing previously processed data, which is really useful for saving time and lowering your costs. Then you have a GUI-based data tool for cleaning and normalizing data using pre-built transformations, and a Glue Studio, right? This is the visual interstate to author and run and monitor ETL jobs. It's pretty drag and drop, so you're pretty good. And then you have Glue Streaming ETL, which would be the real-time ETL using Apache Spark, structured streaming. This would be working with Kinesis or Kafka. All right, so this would be very useful for a finance team who wants to get like an S3 bucket and translate it for something like Athena. That would be a really good example. So remember a couple of things like this. When it comes to security for all the data from any databases, you want to remember the encryption that needs to be used at rest or in transit, especially for the data transfer between the sources, the resources to the ETL position, right? And remember IAM-based controls. So you want to have the correct policies assigned to Glue jobs, tables, or catalogs, right? And another benefit is you can do this cross account. So make sure you have the IAM roles configured for that correctly. So you can have the main account that has all these jobs, has the, let's say, the data catalog, the S3 buckets, and pulls this to run it in another specific account. And then you could assign resource policies to allow other accounts to access the databases and pull this. And then that consumer account is where you would use something like Athena to query the data via the catalog, and then make sure that Glue works with S3, which works with Athena. So the bucket policy would be able to allow access to it. And so both at this time, the policies would be enforced, the cross account would be enabled, and then your output for your visualization with Athena or Redshift or any EMR would integrate with this well. So for the exam, remember the data catalog would be used by the consumers. The Parquet conversion would be useful for the business units to optimize performances. The job bookmarks would prevent reprocessing of previously handled data. The ETL, Glue Streaming ETL, would be good for real-time ingestion from a real-time system like Kinesis or Kafka, right? And then remember to set your encryption for information in transit or at rest via KMS or TLS for transit, and then make sure that your IAM policies are limited enough to allow cross-account access if necessary. Okay, so this will be desktops. Manage desktop as a service, DAS. So this lets you provision virtual desktops in the cloud. So from a security perspective, workspaces includes fine-grained controls to govern who, what, and where users can access from, right? So you have a couple things. You have IP access controls, which will restrict public IP address access or CIDR blocks. And users can connect from when accessing their workspace, right? So here's the key concepts. Remember, there's IP access control, which is similar to security groups, but it's scoped to workspace access sessions. Then you have allowed sources, which is where you specify a trusted IP range. So like your corporate network's public IP, and you can have your VP NAT consideration. So if traffic is tunneled via VPN, NAT, you can allow the public IP of the VPN or NAT device. Then you have to have device access control and trusted devices. So this will restrict which devices can connect to your workspace's environment. So within this, you have the concepts of like trusted device enforcement, which would require the client devices to present digital certificates during login. And you'd have supported platforms, which would work with Windows, Mac, and Android workspace clients, and certificate-based authorization, where an admin will install a certificate on approved devices and connection would be denied if missing. So what this does is prevents unmanaged personal or malicious devices from accessing workspaces and helps enforce bring your own device policies with proper validation. And it adds a device posture check on top of the username or password. Okay. So within this, you have to consider a couple of things with security, right? One, the network layer, you have the IP access, where only known or trusted IP ranges are allowed. You have a device layer where your trusted device is enforced via certificates. Then you have the user layer where the user will integrate with the Active Directory service using Active Directory connector or simple Active Directory, right? Or MFA or single sign-on. And then you have the data layer where the encrypted workspace has volumes at rest, and those are encrypted with KMS, and the connection itself is encrypted, right? But for the exam, remember most importantly, the IP access control, like how does this know to restrict access based on the IP or CIDR range? The VPNs, right? Like what's the public IP of the VPN that must be whitelisted if routing through corporate nets? The trusted device authorization, right? This would require certificate-based authentication and would be enforced by administrators. And then the workspace access security, right? So this will be integrated with something like IAM, MFA, or Active Directory. Okay. Let's see if we can go over some ASG auto scaling groups. Okay, let's see. Um, that's not what I wanted. That's not what I wanted. Instance, is it here? Go back instance refresh. That's not exactly what I wanted. All right, we'll see. I want to find auto scaling. Auto scaling. Let's go over here. Auto scaling. So let's go for, I want to try and find instance refresh, which should be under, yeah, it's not going to be here. Gosh, this is going to be a hard one to find. So this is basically, all right, so auto scaling instance refresh is a native auto scaling group feature that lets you automatically replace all existing EC2 instances in the group with new instances, right? Let's see if we can find it under here. So it'll let you replace with new instances and then use an updated launch template or configuration. So this is valuable if you want to update like an AMI version, instance type, or user data script, or if you have a network or IAM setting in the launch template that you want to update. So let me see. No, nope, it's not here. That's okay. That's okay. So why would you use this, right? So if you were going to apply a security patch, this would automatically replace instances to use the AMI with the latest vulnerability fixes. If you're going to upgrade the instance type, this would move this from, let's say, T3 medium to T3 large and support the increased workload. If you want to update a launch configuration, you could modify your bootstrap scripts or EBS config or IAM roles or tags. Or if you want to replace unhealthy or outdated nodes, this would ensure all instances comply with updated standards. So this is a good way to have a healthy environment. So you want to remember a couple of things like the healthy percentage, like the X percentage of instances remain healthy during the refresh. Your warm-up time, which would be like the wait time before considering new instances as healthy. Your rolling update, which would be a phased replacement instead of a full teardown. And then your launch template, which is a blueprint and how you would apply this to all new instances, right? So the feature is frequently paired with security operations like enforcing STIG or CIS compliance via updated AMIs, or refreshing EC2s after secrets rotation or user data changes, updating IAM rules or permissions via new launch templates. And the exam may combine instance refresh with these security questions to test your operational understanding. Okay, so remember that this is a manual trigger. This does not automatically refresh. This is a controlled rollout. So you would use the warm-up time, the health checks, and this would prevent outages of your workload handling. And it's a security application, right? So this is commonly tested alongside other resources that would be used here, like your AMI or any compliance issues, okay? EBS, so this is going to be over EBS. Should be volumes. There you go. Volumes. Okay. So the EBS block store provides a persistent block storage for use with EC2 instances, right? So a common concern in cloud security is what happens to data stored on EBS volumes after those volumes are deleted. So this often appears on the exam, and it's used to test your understanding of data sanitization and secure delete practices. So what happens when you delete an EBS volume? When it's deleted, the physical storage blocks that back the volume are not immediately reused. As is. So instead, AWS performs zeroing, where all blocks are overwritten with binary zeros, and this ensures that no residual customer data remains. Only after this wiping process is complete can the blocks be reallocated to another customer's volume. So this is an important clarification here, right? Some people have a misconception that you must manually wipe the data before deleting the EBS volume, but in reality, you do not need to manually wipe or overwrite data on EBS volumes before deletion. AWS automatically sanitizes the underlying storage before it's reused, right? So the behavior is part of AWS's shared responsibility model, where AWS is responsible for the secure handling and reuse of storage infrastructure. You're responsible for your side of the application, okay? So this would be something that would be compliant with NIST 800, right? Or ISO 27001, or SOC 2, or PCI, right? So this is part of the reliable data destruction methods, and AWS would meet the requirements through zeroing out with this mechanism. Oh, and if you wanted to, like, let's say, reuse volume yourself, if you detach it but don't delete the EBS volume and want to ensure your own data wiping, you can do that with a command line code. Okay, it's optional and it's only necessary if you're repurposing the volume within your own account. Okay, so AWS Cloud Shell. All right, so what is Cloud Shell? Cloud Shell is a browser-based shell environment built into the AWS console. Let's click on this one. Show you that. All right, so it's designed to let users interact with the AWS resources securely and efficiently without having to configure their own local development environment. So it's frequently tested on in the exam, especially in the context of secure CLI access, automation, and permissions. All right, so this will have a couple of pre-installed tools, right? The AWS CLI, the SAM CLI for serverless, ECS CLI, and SDKs for Python or Node.js, and shells like Bash, PowerShell, or ZSH, right? And within this, you'll have secure AWS credentials inheritance, where Cloud Shell will automatically use the IAM credentials of the logged in user. And so there's no need to run the AWS configure command, right? And it comes with 1 GB of persistent home directory storage per AWS region. So I showed you where it's accessed from this little button here. And it's in browser terminal, no need to install or manage any local tuning or tooling. Let me think. Also newly added, you can launch Cloud Shell in a VPC, which is known as a VPC environment. So within this, you can have direct private network access to EC2 instances, RDS databases, or other VPC-bound resources. So this is valuable if you want to secure automation or troubleshoot or do any database operations without public endpoints. For the exam, just remember that this is a credential source, right? So a Cloud Shell will use the IAM permissions of your user. There's CLI pre-configuration, so you don't need to configure this for your local environment like you would if you were logging in from your Visual Code editor. It's regional storage for persistent storage per region of 1 gigabyte. There's in-VPC access to environment-bound resources, and you should always use least privilege when you're accessing all of this, which is just a good general security practice. And so these are going to be databases. Let's see. This is very basic. Okay, let's go over here. This might be command stuff. Is this gonna be just documentation? I hope it's not. Okay, it'll bring us here. Okay, so RDS and Aurora are fully managed relational database services with built-in security capabilities. So these services are frequently covered on the exam, especially in topics like encryption, IAM authentication, and secure access. So a couple of things you need to remember this. Encryption at rest. You need to have this enabled. So this would be KMS-based encryption. So it's used to encrypt something like the primary database instance, any read replicas, only if the source is encrypted, automated backups, snapshots, and logs. And an important constraint, you must enable encryption at creation time. You cannot encrypt an existing unencrypted database directly. However, if you need to work around, you could take a snapshot of the unencrypted database, restore the snapshot into a new encrypted database. With encryption in transit, you would usually have this set up to support TLS encryption. This does it by default. You can use SSL or TLS root certificates provided by AWS when connecting from a client. But a best practice would be to always connect via the TLS-enabled port to ensure encryption. Regarding IAM authentication, this would be passwordless login. This would be supported for MySQL, MariaDB, or PostgreSQL. So how it would work would be you would attach an IAM role to the EC2 instance, and then to the calling EC2 instance. And you'd use the RDS API to request a temporary authentication token. So that would be valid for about 15 minutes or so, and use that token over an SSL connection to connect to the database. So the benefit for this would be there's no need to store or rotate passwords manually. The centralized access control using IAM, and then it will integrate with the EC2 or the Lambda using the IAM role. And then regarding networking, so the VPC security groups would control access to RDS or Aurora from other resources. And so there's no SSH access to RDS instances since they're fully managed by AWS. One exception would be RDS Custom, which would give operating system level access. And then for audit logging, this would work with CloudWatch logs. You get general logs, slow query logs, audit logs, depending on the database engine. But a benefit of this would be that you have longer retention, centralized monitoring, and it's easier to analyze for security operations and compliance. So just for the exam, remember, unencrypted snapshot, that's not going to be able to re-encrypt this. So you take a snapshot of it, then you restore this onto an encrypted cluster, and then go forward, okay? An encrypted database creates an encrypted snapshot, okay? And this would be automatically encrypted, and then an encrypted snapshot from a copy, you can copy that while retaining encryption, all right? So snapshots follow the encryption status of the cluster they're derived from. All right, so a couple of reminders for the exam. Encryption is not retroactive, plan it up front. IAM authorization is more secure and centralizes identity control. You cannot encrypt an existing unencrypted database snapshot directly. And RDS does not allow SSH except for the custom. Okay. Go for that. All right, image builder. Okay, so what is image builder? All right, so Image Builder is the fully managed automation tool that simplifies the creation, maintenance, validation, testing, and distribution of Amazon machine images, AMIs, right? And the container images. So Image Builder is an automatic creation of golden AMIs or Docker images. So you could use this for operating system hardening, security patching, installing dependencies like Java, AWS CLI, validating secure configurations. So once this is done, this delivers a validated, secure, and reproducible image across accounts and regions. So how does this work, right? One, you have the build phase. And you can look through, you'll use all of this, right? So you would launch, let's say you launch a temporary EC2 builder instance to run a predefined component script. This would be something that would install different packages. It would pull them from public or private or AWS or managed repos, right? It would install this, package it, patch it, perform some customizations like installing Java or CLI or something along those lines. Then after the configuration, the AMI would be created from the builder instance, right? And then it would launch a test EC2 instance using the AMI. And then if it runs functionally and passes security, you could share this across regions or accounts. You only pay for the build, the resulting AMI storage, and any resources like logs in S3, right? So key things to remember. So you have the image recipe, right? So this defines how the base image is customized. So this includes the source AMI like Amazon Linux 2, Red Hat Linux. You have the components. Does this install Java or AWS CLI? And you have the versioning and architecture. So you can set this for AMD, you can set this for x86, and then you can set your versions within this image type. Version 1.00, 0.01, 0.02, et cetera, right? And then you create your infrastructure. So this would be the EC2 instance type. So this would be T2 micro, T3 medium, T3 large, on and on. The IAM instance profile with required least privileges and permissions, and then the network settings. So this would be the VPC, the subnet, the security groups, right? And the test configuration is optional but recommended. So this would define custom validation scripts to check like if services are running, if security settings are enabled, if network rules are enabled, but it can be skipped, okay? And then you can set this up to be distributed across regions or accounts. So US East 1, US West 1, or if you have like a dev, prod, release control environment. It's very useful. It's good for global deployments of those golden AMIs. So you can do this on a manual run, or you can do this on cron expressions for regular builds, like every Monday at 9 a.m., update that golden image. And you can trigger based builds based on like a package or dependency update. All right, so some things to remember for the exam. EC2 Image Builder supports automated, secure image pipelines. It's ideal for a golden AMI strategy, CIS hardening, patch management. Watch out for your IAM issues, your S3 permissions, and any region-specific distribution settings in the scenarios, all right? And then remember, default AMIs are not always secure. So using Image Builder ensures repeatable and secure provisioning. Okay. So it's Redshift. Redshift is a fully managed petabyte scale data warehouse. So security in Redshift includes identity, access control, and data level protection, both within the database and at the cluster level, right? So here's some roles and hierarchy, right? So let's go in here. Okay, so within this, you'll see there's a super user, which is created when the Redshift cluster is initialized, which has full administrative privileges on all databases and objects. Only a super user can create another super user. Then you have the user, which is created or dropped by super users. This can own databases and objects like tables, views, or whatnot, and can be granted privileges explicitly or implicitly via groups. Then you have a group, which is a logical grouping of users, which is useful for role-based access control, RBAC. And the permissions can be assigned to the group, and all members inherit them. Then you have the database. So this is a collection of one or more schemas and can be created by users. They become the owner. Super users always retain full access. And then you have the schema. This is the logical grouping of database objects. So access can be granted per schema to users or groups. This is used to manage permissions at a finer granularity. So some permission inheritances include explicit, where it's directly granted to a user, or implicit, which is inherited via group membership. And with authentication, you have a username or password, which would be the traditional way. This is the default way for users to connect to Redshift. You have IAM-based authentication, which uses the Get Cluster Credentials API to generate temporary credentials. So this requires users to have appropriate IAM permissions, and supports pre-existing users and auto-creates users with the auto-create equals true permission. So the benefits of this would be centralized identity via IAM and short-lived credentials for security. So within this, remember, auto-create equals false. This would be an IAM role mapped to an existing Redshift user, or another option would be auto-create equals true, would be a role mapped to a new user created on the fly, which would be useful for federated access. And then you have a DB user password disabled. So this would force login only with IAM credentials. Okay. And then let me see if I can get a nice image for you to visualize. All right, so this would be the Redshift cluster. You can see how that's set up with the super user up here. Super user, the groups, and databases. Okay, so some security best practices for this would be enable IAM-based authentication for federated users or external systems. Disable passwords for users that must only authenticate via IAM. Use groups to streamline permissions management. Audit schema permissions to avoid accidental privilege escalation. Update group privileges when new schemas are created, and apply least privilege principles across users and groups. Okay, and remember for the exam, Redshift supports IAM authentication similar to relational databases. You can't use IAM roles to access Redshift directly. They grant permission to fetch credentials, not to query Redshift itself. Temporary credentials have a short time to live based on the session and reduce the attack surface. And also remember to pay attention to auto create true versus false and group level access management and multi-schema environments. Now let's go for DynamoDB time to live. Hold on. Okay. Now, DynamoDB. Okay, so DynamoDB has a time to live, right? This is a built-in feature of DynamoDB that automatically deletes expired items from a table based on a timestamp value stored in each item. So time to live helps manage storage costs, enforce data lifecycle policies, and comply with security or regulatory and retention requirements. So what is time to live? It's an attribute. It's a user-defined numeric attribute in Unix epoch time format. So it's like January 1st, 1970 UTC, right? Universal Time Code. So the expiration has a logic to it. So when the current time exceeds the TTL timestamp, the item is marked for expiration. And so the deletion is asynchronous and usually occurs within 48 hours, but there are no strict guarantees for immediate deletion. Okay, so you just have this set up with the let me see. You can have this set up with a time to live attribute. And so when it's hit, the background will process to later delete the item. Right? So some benefits of this are cost savings. So this will automatically remove stale or obsolete data, reducing storage costs. Security and compliance. So this will help enforce data retention and privacy policies, like delete things after 30 days. Database hygiene, right? This will keep the database lean by removing unnecessary historical data. And session and cache management. So this would be useful for temporary data like user sessions, API tokens, or one-time passcodes. So a couple of implementation notes that the TTL attribute must be a number and must contain a Unix epoch time in seconds, not milliseconds. The TTL must be enabled per table. Only one TTL attribute can be defined per table. The expiration does not generate DynamoDB streams events by default unless streams are configured. Deletion is free and does not consume write throughput, and you cannot restore expired items once deleted. All right, so remember this for the exam. Is the time to live, does this delete things immediately? No, it's eventual. It could take up to 48 hours. Can you set this on a secondary index? No, it only works on the base table. Does it use write capacity? No, it's handled by a background service. And does TTL help with GDPR? Yes. It can enforce time-based data retention. So to summarize, TTL automates deletion of expired items based on a timestamp. The timestamp must be an epoch formatted numeric attribute. The deletion is eventual, not immediate. It helps reduce costs, enforce retention, and manage session-like data. And some common use cases would be session cleanup, temporary data, or GDPR or HIPAA retention policies. All right, so this would be the last portion of the AWS Security Specialty walkthrough. We're going to release a couple more pieces after this, and I hope you enjoy those. But I hope you enjoyed walking through this with me. Thank you again, and have a good day.